Part B. So I hope you can pause the video and try this problem first. So everybody please learn how to use your calculator. So input the x values and y values. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 points. So input that in your calculator. And then you can find use your calculator and you find x bar, y bar, sum of x squared, sum of y squared, sum of xy. So get this from your calculator. Okay, and what do I get? Well, remember we have 10 data points. X bar is 32. Y bar, sample mean of y, is 63.5. Sum of x squared is 11490. Sum of y squared is 41395. Sum of xy is 21275. Okay, do you get the same answer? Okay, so then next we're going to show our work to calculate the regression line. So how do we calculate? Well, SXX is sum x squared minus n is 10 x bar squared. Sum x squared is 11490. 10 x bar is 32 square. Okay, so what do we get? We have plug this in your calculator and then you get 1250. Okay, and what is SXY? That is sum of xy minus 10 x bar y bar. Sum xy is 21275. Minus 10, x bar is 32, y bar is 63.5. So plug this in your calculator. What do you get? I get 955. Okay, next. The B is then SXY over SXX. Well, that is 955 over 1250. And I got 0.764. Do you have the same answer? Then A is then y bar minus bx bar. Y bar is 63.5. B is 0.764. X bar is 32. Plug this in your calculator and I get 39.052. So what is the regression line? Y hat is A plus bx. A is 39.052 plus B. B is 0.764x, right? So find the regression line, we just use the formula, so very easy. Okay, so I want to ask you questions. What is the error sum of square? Okay, so to calculate the error sum of square, then we need SYY. So that's sum of y square minus 10 y bar square. Sum of y square is 41395. Y bar 63.5 square. Okay, so plug this in our calculator. Let's see. 41395 minus 10 times 63.5 square. I get 1072.5. Do you have the same answer? And then what is the rest of sum of squares? So sum of the EI square. That equals, by the formula, SYY minus SXY square over SXX. SYY is 1072.5 minus sxy is 955 squared over sxx. So 1250. Okay, so what do we get? So we get, put this in our calculator. I got 342.88. Do you have the same answer? So that is the residual sum of squares. That's the error sum of squares. Okay? Alright, so that is example 3. You can see in example 3, we are predicting y from x. But sometimes we may also predict x from y and get a different regression line. Okay, let's look at example 4. So given that the data n is 5, x bar, y bar, sxx, sxy, and syy. Oh, they're all given. Okay, sxx, sxy, and syy. And part A, find the least square line for predicting y from x. Part B, find the least square lines for predicting x from y. Part C, compare both y's. Okay, so part A is like just what we have been doing, right? So we use the formula y is sxy over sxx, sxy 17A40.1, sxx 7239. I say 39, but I put 93. And plot this in our calculator. What do you get? I get 2.46436778. So I want to make it longer enough because I want my answer to be more accurate. So then A is y bar, sample mean of the y values, minus b times x bar, sample means of the x values. So y bar is 305.58. B is, that long number. And then x bar is 88.34. Okay, so plot this in our calculator, and then I get 87.87776. Okay, so my regression line y hat is a plus bx. A is 7776 plus b is 2.4643, 5 decimal places. 4, 7. X. Okay, so that is the regression line. This is like what we have been doing. Okay, part B. Find the least square line, the regression line for predicting x from y. Well, what does that mean? So you consider x depend on y, so y is like the independent variable, x now is the dependent variable. So it's like the rows of x and y switch. So we switch the rows of x and y. What does that mean? It means all the numbers in our formula, we just exchange x and y. So now my b is syx over syy. Oh, but syx is the same as sxy, right? Because multiplication is commutative. So that's 17A40.1, and then syy is 66975.2. Okay, plot this in our calculator. I get 0.266368745. Do you have the same number? Okay, good. And then A is, remember we switched the rows of X and Y. Then A is gonna be X bar minus BY bar. X bar is 88.34. B is 0.266368745. Y bar is 305.58. So far, so good. And let's see. So plug this in our calculator. What do you get? I get 6.94304. Okay, so our regression line x hat is then a plus bx. A is 6.94304 plus 0.2663669. Why? So far, so good, everybody? Okay, part C. We want to compare both lines. Well, a natural question is, well, our second line is like is x equals to some y. So natural question is, if we solve for x, so here, if we solve for y, do we get the same line as in part A? That's the natural questions, right? Let's do that. So when we solve for y, how do we solve for y? First, divided by, subtract 6.94304, right? And then both sides divided by 0.266369, right? 0.266369. And then I get y is 1 over 0.266369 is 3.75419x. And then 6.94304 divided by 0.266369 is 26.0655516. All right. Let's see. Is this guy and the answer in part A, are they the same? Oops, not the same. And actually, it makes sense if they're not the same. Let me show you why, okay? So, suppose we have a set of data points. Let me see, what color do I use? I use orange. Okay, so suppose we have a set of data points. Maybe like that, like that. So we have a set of data points, okay? Supposedly like that. And then, part A. So part A, we construct, the regression line such that this area, that error, those EIs, sum of the EI square is smallest, okay? And for part B, we switch the row of x and y. So the regression line we get from part B. So let's say this is part B. The regression line we get from part B is actually we get that horizontal error. So instead of the vertical errors, we have the horizontal errors. So the line is designed such that the horizontal errors are smallest. Okay, everybody? But the two lines, they all pass through a point. Okay? So what is this point? They pass through the points x bar, y bar. Okay, so that's why, let me call, this is equation 1, this is equation 2. Okay, so, sorry, let me call this guy equation 2. So, 1 and 2, they are different lines, but they both pass through the points x bar, y bar, okay, which is 88.34 and 305.58. Okay, and the choice of the regression line depends on which variable we wish to predict. The choice of regression line depends on which variable we wish to predict. Okay, so if we want to predict y in terms of x, then this is like what we have been doing before. If we want to predict x as a function of y, then it would switch the role of x and y. Okay, so let me just put some more. So this is the EI, this is the EI plus 1. Okay, the orange line I designed such that the sum of EI squared is the smallest. And the green line is we want the horizontal distance to smallest. So let's say this is DI and this is DI plus 1. Maybe this guy is DI minus 1. So the green line is designed such that the sum of DI squared is the smallest. So far so good. So that's why they are different lines. Alright, fact. The true mean of y, okay, which is mu. So, or if you like notation, mu is the mean of y, is a function of x. Okay, so it's a linear function, alpha plus beta x, and y hat equals a plus bx is an estimator for the mean mu. So a and b are the estimated values for alpha and beta. So the true mean is beta, so it's alpha plus beta x. The regression line we calculated is the estimator for the true mean. Okay, so this is the notation. We have parameter and we have the estimator. It's like in chapter 7, our parameter is the mean and our estimator is the sample mean, right? We use sample mean to approximate the population mean. So far, so good. So that is session 11.1. So don't forget the appendix, you can see the proof of the regression line formula. When you have questions, feel free to ask me. And this is the last session of our class. So I will miss you a lot. So I will see you in our office hours. Bye. Have a great summer.